basically the preface is I was working on the next version of the terminal debugger, and
Okay.
I got some amount of the way there, as in I think it can do something like this now. So I got this amount there. I can step now.
Nice.
I can step in, I can step out, step
Okay.
into, step over. I don't have the variable display yet. And that's partially because that's the part that I want to integrate your tree UI work
Okay.
in, but also partial because of the next thing that I'm talking about, which
Okay.
is oh, and also previously it was the JSON like parser. Need that to get the heap data structures in.
Right.
But as I was working on this, it took longer and longer to recreate the past states for the log file.
Mm-hmm.
And I decided I think I kind of have to do something about this if we're gonna be able to do this for work on a day-to-day basis. And even though it wasn't really bad, I felt like the longer I used the UI, like the more times I stepped, the longer it would take. Which means like it's very soon gonna be impractical that the more we do the UI. So I wanna I thought about how to solve the problem, and one of the things I learned from the chat with Bill Lewis is the way he does it is more efficient in terms of space storage. So I'll show you what I mean. Oh, and let me go this one. Okay, so something like that. If you scroll through, like these are all the objects in the heap, and I represent the value of a composite object in this way. It's like a sort of like a JSON object,
Right.
But either the key or the value could be a reference to another object in this table, which is signaled using this caret.
Okay.
The problem is you can see there's kind of a lot of repetition of data, right? This row is mostly like this row, is mostly like this row. You can see there's one more entry added.
Right.
As I click down, that means like maybe the dictionary is getting more and more entries as the program is progressing, right? But that does tell me there's a lot of repetition of data here, and this is inefficient use of disk storage space, right? So, and also we have all of these objects that are, even though this is kind of trivial, but it is still, the tag name is kind of long and there's a lot of repetition of this tag name. So my theory is that the time it takes to generate the data in this database, a lot of it has to do with just the sheer amount of data we're writing into this database. And if we can remove a lot of the repetition, that means we'll get a much smaller database and also much faster runtime needed to generate the database.
Yeah, that makes sense.
So that's what, so yeah, like this, you see, wow, there's a lot of repetition here. Like something like this. If we got rid of the duplication, we should just get much better size, but much smaller size, and also much better performance.
So how does that work?
What's the proposed scheme?
Yeah,
So the
exactly.
proposed scheme is, so the reason I did it this way is because I came to this with the mindset of immutable data structures, because
Okay.
because I started off with, Redux. That's where my head was. I was thinking about
Uh-huh.
Redux and, you know, functional programming, immutable data structures. That's
Mhm.
and Git. I really like how Git does things, and that's based on immutable data structures.
Mhm.
And that's why I had things represented this way. Whenever I make a change to an object, I make a new version of the object with the added change to it. But instead of modifying the old one, I make a new one. Um, and there are ways to shrink things, even
So
if
are you gonna only record the change and then you just like go from like state 0 and then add a change and
Mhm.
add a change and then
uh,
recreate?
I don't want to do that, because if I did
Okay,
that, that means in order to go back to any point in time, I have to replay some of the things, right?
that's true. Yeah,
And I don't want to have to do that, because the point of this database is you can jump into any point in time very quickly without having
that's true.
to replay anything.
Uh-huh.
So the plan is actually to, um, add a add one more level of indirection. Um,
Okay.
so the key being, composite objects, and this is, I honestly, I'm stealing this from Bill Lewis's Omniscient Debugger. I read his paper,
Oh,
and this is how he does it. As far I
uh-huh.
can understand his language in his paper. Basically,
Uh-huh.
if you have any composite object, which includes lists, dictionaries, objects, um, in JavaScript terms, maybe this is like this. Um, so currently, I'm saying, if I wanted to add a new property, I'm gonna have to just make a new object and save that. But instead of doing it this way, what I'm gonna say is, I'm actually gonna have an object. First of all, each object has an ID.
Uh-huh. Oh, is it like an expression like object 1 plus object 2 and then you get the object 3? But
No,
that's
no,
mhm.
no. It's I can see where you're going, but then you have to
Uh-huh.
remember what expressions give you the object, and you have to go back to compute the expression in order to
Uh-huh.
get the object.
Mm-hmm.
Um, I don't know, but my plan is actually this.
Okay.
This is gonna be, even if currently I have these references already,
Right. Yeah.
I'm gonna make everything a reference.
Sure.
Even if it's a number or a string, like a primitive type, I'm gonna make these references.
Okay.
And therefore, um, now if so, well, okay. So first of all, if you change the age, then object 3 used to be 19. We're gonna change object 3 to 20. And you say, how do you change? It's immutable. The way you change things in an immutable space is you add a version number.
Okay.
So, so like 3 at version 1 is 19, and 3 at version 2 is 20 now.
Right.
And maybe this
Uh-huh.
is 1 at version 1.
Right.
One is this person object, and one's name is pointing to 2.
Uh-huh.
Maybe at 2 at version 1 is Bob,
Right.
and so forth. So the one more level of indirection here means whenever I make a modification to the person object, I'm not changing the structure. I'm just
Uh-huh.
changing the leaf value. But by change, I don't mean change, but I mean add a new version of the value at the leaf level, which does not disturb the parent level at all.
So what do you do when you add a property? And then
Okay. So when we add the property is more complicated because so what I decided, and you can critique me on this because I just came up with this. It might not be good. So what my thought now is, in order to deal with these, if any composite object is going to have a number of key or a number of entries, right, inside the composite object. For dictionaries, the entry is a key value pair. For lists, I can look at it still as a key value pair. It's just the keys are integers.
Okay.
So that's the thought. So for each entry inside a composite object, I'm gonna have separate database rows in order to represent those. So it actually becomes one is an object, and then I'm gonna have an entry one name points to 2. Entry one age points to 3. And so this represents the, this is saying, hey, 1 has an entry of name and it points to the object 2. And 1 has the entry of age and it points to the object 3. But
it's like a one to many, basically. It's like a one to many from an object to version, and then it's another one to many from version to property.
Yes, that's what it is. But in reality, the key is not a string necessarily. The key can be anything in Python, actually, anything that's hashable. So this actually becomes another reference to another thing. So okay, for the first version of 4 is the string name, and then we have to do something like that. And at this point, it's like you're like, wow, this is a mind bender. This is really this is like I have to follow a lot of leads just to get the full picture, kind of thing.
Right.
Everything has been made very indirect. I would think that does make things harder to debug, unfortunately.
That's true.
But and I don't have a great answer to that necessarily. I don't have a solution to that. That is a disadvantage of this approach. Whereas with the current approach, the way it's implemented now, debugging, okay, it's not extremely easy, but it's relatively straightforward. I can look at, that object. I can, figure out the point in time of a certain, heap object. I can look up its version number to find out which object represents its state and go look up that object. And I know what the object looks like. Whereas with this one, I will need a SQL query that will be able to combine the entries with the original object and then join it again to the actual values in order to figure out what the object actually is. So to answer the question, if you want to add a gender and add another entry to this object, we're gonna add, another. We're saying object 1. There's also a version number There's also a version number inside the entries as well. So version 2 of object 1 has this entry, and then maybe this is 6, and then it points to 7, and then 6 is the string gender, and then 7 is gonna be the string male. That's how we add an entry.
Oh, so what's the difference between the two numbers after entry? Like which one is which one's version? So
Oh,
I
this one is the ID of the container of the entry, which is this guy.
okay, okay,
And this, empty object, that doesn't doesn't real matter. That it's empty object plus its entries, and then
uh,
this is the version number. Version number is like the overall, like it's a global number within the whole
uh-huh,
application. It's the
oh,
current state of all the objects. That's what that
okay,
represents. So the
oh,
state one of the whole application, uh, I basically gather
mm-hmm,
all the things that are tagged with that version or less.
mm-hmm.
That's how I figure out what things are at version 1 of the history of this program.
Wait, you did this for something before, right? Like a similar thing, but not for the object. Just use
Yes,
like versioning.
you're right. I did this for the heap.
Uh-huh.
I did this for the heap,
Okay.
uh, where like this heap ref table is means this heap ref is a reference to a heap object in memory of the program,
Okay.
and this ID is actually a unique identifier that identifies a heap object in the program. And a heap object is a list, is a dictionary, is an object. Those are all
Mm-hmm.
heap objects in Python. But in more general terms, a heap object is something that's allocated in dynamic memory instead of in the local variables of a function. And it stays around for longer than a function is finished.
Mm-hmm.
And this heap version, this heap version is that state version number of the entire application. So this is heap version 2 means the not necessarily time 2, but it's the second version of the entire state of the entire application. And
Mm-hmm.
anytime anything changes in the state of the entire application, this version number goes up by 1.
Okay.
And
Gotcha.
so this is and anytime you make a change to anything, we're going to get a new entry here with the next version number.
It's, well, I guess how I see it is like, can you see like the whole state of the entire application as a big object?
Yeah,
And then
yeah,
it's just the same idea as what you did for the object. This is just
exactly.
another layer on top, but it's exactly the same.
It is exactly the same. I did this transformation because before I did this architectural change, my heap was actually represented as a huge object. and, and
Okay.
that was so ridiculously bad that
Uh-huh.
I said, yeah, I have to do this. But I think now I have to do this even at a finer grain level for all the
Gotcha.
individual objects.
Uh-huh.
So
Well, I think that's not totally like uncomprehensible. What's
mhm.
the word? Like I guess that's I guess since you explained it to me last time about the heap, now it's like kind of I can like basically understand this. And then
Mhm.
also just with one SQL query, you can get what you need. So
Yep,
it's not that
that's true.
bad, I think.
It isn't that bad. I mean, if it was really bad, that I probably wouldn't do it. But on the other hand, it does make debugging difficult because I imagine it will make it hard for me to just browse through this data and see what's going on.
You just have to use SQL
Yeah,
instead of
I have
browsing.
to have this. I have to have a bunch of little utility SQL
Yeah.
statements, and then go in here and paste them in, and then run them. Or maybe build some sort of tool, some command line or graphical tool for me.
Yeah.
And ultimately, the debugger is the ultimate graphical tool that helps with all of that. But
Yeah.
that has to be bug free before it can be useful.
That's true. Yeah.
Yep. Yeah. So that is the plan, and I'm hoping that they will give us a big performance boost, and a much, disk storage, much smaller disk usage.
Nice.
So, but obviously, if we do that, that means like the JSON like language is out because we're
Oh,
not we're not even gonna serialize the data anymore.
oh, that's okay. Yeah.
Right.
Well. Yeah.
So
Well,
so mhm.
it's a nice cost for us to make the closure experience better.
Yeah.
Like, yeah.
Yeah. So if you look at the log file right now,
Uh-huh.
the log file is uh, okay. So the log file kind of looks like this. You can see the generated SQLite database is roughly double the size of the log file.
Okay.
Like 659 for the SQLite
Sure.
database,
Uh-huh.
323 for the size of the log file.
Okay.
Another example, this is the time nav tool I've been working on.
Uh-huh.
4.5 megabytes for the log file and 10.5 megabyte for the SQLite database. So the SQLite
Uh-huh.
database is even more than the log file, which or immediately tells you, yeah, there's a lot of data duplication, right?
Uh-huh.
And because even this log file, this log file is not that efficient in terms of um, serializing the data. There's a lot of unnecessary characters in this log
Okay.
file. It is not very streamlined.
Okay.
So if even that is the case and your database is still double the size of this log file, that's clearly
Mhm.
inefficient. So I'm hoping that we'll get a huge reduce in the size of the database, maybe on the order of 5 to 10 times less.
Oh, wow.
That's my hope. We'll see how it actually goes.